So today I'm going to show you how to run an overhead on one of these Cat 3114, 3116 engines, the mechanical engines that have been around for 30 something years. One thing that's important on these is if you are putting new injectors in, or you're installing the injectors, and you're installing them on a used head, new cylinder head, whatever, the injectors need to be properly sealed. These are notoriously bad about leaking combustion into the fuel pump, and you always need to seat the injectors. So this is the actual proper tooling that Caterpillar has for that. It's quite expensive, but it is quite important to do. You can make this tool just with a piece of plate, and I've used a pipe nipple before, and I've ground this down. I have another video posted where we actually do that with the homemade tooling. You can go look at that. If you're just running an overhead on one of these, then you don't have to do this process, and we can just continue on. Okay, so today I'm going to show you how to run an overhead on a Cat 3114, 3116, or 3126, the mechanical unit injected engines. I've been wanting to make this video for over 20 years, probably since before YouTube was actually a thing. Anyway, I'm going to show you how you can do this without all of the factory tooling that Caterpillar requires. You can do it with just a very few tools for less than $200–300. Anyway, there's a couple preliminary things that need to happen before we do this. I'm going to show you some stuff, then we're going to put this together. First off, the fuel shutoff solenoid needs to be removed, or if it's in a truck, you can just turn the ignition on. You can also, if it's in a piece of equipment, you can turn the key on and you can just crank it quickly and it'll put it in fuel on, and it'll stay in the fuel on position while you do the entire thing. For this, we're going to remove this. Okay, so this needs to be off or out of the way. It needs to be in the fuel on position, one way or another. Okay, so we'll do that. The next thing we need to do, if you don't have the rocker arms, and you can do an overhead with or without the rocker arms, it does not matter. I'm doing it this way so I can show you some things on it of how to do this properly. Okay, so with the fuel injectors installed but the rocker arms off, you have to press each one of the fuel injectors down 1/8 of an inch, maybe. They just have to be just slightly compressed. You can do that with some sockets, a bunch of nuts, a bolt, some small pieces of flat bar. You don't have to have these actual parts, but they do have, every one of them has to be held down. And then, like I said before, the fuel shutoff solenoid has to be removed so that the rack moves freely. And it has to be very, very free, like this. So when we get to this point, I'm only gonna do 1 or 2 of them, then we're gonna put the rocker arms on and we'll finish the rest of it. The tools that you need to do this is a Caterpillar tool, and I would recommend buying this tool. The part number for the tool is a 1U6673, and it's a little over $100. And when I checked in January of 2025, it was still available through Caterpillar. If you want to make your own, this is a 2mm Allen socket or a 5/64 SAE also fits. And you can just take that and you can use a piece of welding rod, and then you can get a small socket, and the socket is a 7mm socket, and you can take a piece of brake line tubing or whatever, weld these together and make your own. You can do it just with an Allen wrench and with a socket and a ratchet. but it's difficult. This is what locks the set screw in place. So it's difficult to get it in, turn it into place, and then lock it into place without this tool. So this is one tool that I would recommend buying. All of the rest of the tooling in the kit, which the kit is over $3,000, can be done with just a caliper. I prefer a digital one that measures in metric because the fuel settings, the timing settings for the fuel injectors are a metric dimension. We'll get into that a little bit later. But basically this tool, a pair of needle nose vice grips, and you need the thinnest ones possible, and a set of feeler gauges is all you really have to be able to adjust one of these overheads. I have the tooling, I own the tooling, and I use the tooling, but I still prefer this way of synchronizing my fuel injectors because it's faster and it's every bit as accurate as the factory tooling that there is. The problem with these racks is these racks move back and forth like this, and especially if you get one that's got some age to it, they get a little bit loose and a little bit sloppy. And so no matter how precise you are, everything can move around a little bit and it always comes off a little bit. One other thing I suggest when you're doing this is this little arm down in here, there's a rivet that holds the rack control arm into the governor. That rivet can work loose sometimes and then it'll be sloppy right there and you can have power problems because of that. So whenever you got the rack off, check that, make sure that's good and tight. Now what I do, the way that these work is the number one fuel injector is non-adjustable. You'll see it's missing the set screw and the jam nut. That's deliberate. They want that to be fixed with the governor. And then everything else synchronizes to the number one fuel injector. So what we do is we take every other one of these and we move them in a ways so that they're not in a position to bother us while we're synchronizing them. So loosen them. Wow. And we get every one of them. Okay, now, when you come down here, the first one, the number one fuel injector, will stop moving. You can see that it'll quit moving here. And then as it stops moving, the other ones, the next one down, will come down and it'll move. Okay, so now that I've moved all these out of the way, you'll see number one comes down and it stops. Then number two, as I rack forward, has a little bit more that it continues on. Now you can feel that. This is very, very difficult to film or show, well, or explain to anybody. It's much easier to get a feel and show it in person. Anyway, from this point, we take number one stops, and then you feel a light bump, an ever so slight bump from this. And then you back it out, and you'll continue to back it out. And you have to be able to put your eyes on two racks at once. So what I do is I watch the number one stopped, where I feel comfortable where it stopped, and then I give it a little flick of my finger to see the other one move. I'm sure that this is why the tooling is so complicated is because trying to explain this to somebody of how to do this is very, very difficult. I'm going to exaggerate it and show you what happens if you go too far, just so you know what you're looking for and where you're looking for. Okay, so now the number 2 fuel injector will hit first, and you can feel that light bump. The number 2 fuel injector will hit, and then the number 1 injector shows visible movement. That means you've gone too far with your synchronization. So we'll go back in here. We come back down till number 1 stops, and number 2 there can be no visible movement, and you need to get the very best light you can get. You need to get all the situations just right to be able to feel this, and it is tough to feel. But with the practice, the big thing is you want to feel the very, very light touch, and you can feel when the 2 of them are good. Now I feel pretty good about that right there. So I'm going to lock this in place. This is why the little tool is so handy. Okay, lock that in place. Check it again. Okay. And again, like I say, you can feel the bump, the first stop, then you can feel the second stop. Now, if you look down here further, as we go down further, you can see that now number 1 and number 2 have been synchronized. Now number 3 has more movement in it. Okay, so now we're going to take and we're going to back this down here to where we get the same thing happening here. Let's do a little more. And this takes quite a bit of practice to feel what you're looking for, and it's just an extremely light feel. Okay, I feel pretty good about that. Now, when you're doing this, don't sneak in and try to be real smooth like that. It's better to be a bit aggressive with them and move it and let it flex. That kind of takes up the slop and takes up different inaccuracies that are there. I found that a quick jab, and then as you get to the edge, you're looking for this light touch here. And sometimes after you get all done, you go back and you do them again, you'll find noticeable movement in one or two. I've taken the actual factory tooling after this, after I've attempted this setup, or after I've done this, and I'm within spec. I think spec is like 0.02 millimeters, and I'm well within spec of doing this. The reason why I came up with this is because what can happen, you can see this movement back and forth right here in the rack. Well, over time, all that wear gathers up, and you've got wear in little balls, you got wear in the little sockets, you got wear in everything else, and it'll throw these things out of spec. You can have it perfect and move the rack one direction and it'll be out of spec. So it's not as critical as they lead you to believe. Also, if you've ever worked on any 2-cycle Detroit diesels, they did the exact same thing with their synchronization, and they only had a small tool that you pushed here and it would ramp back, and that's all that they ever did with them. This is very similar if you've ever been around any 2-cycle Detroits. Okay, so we've done 3 of these. Now what we're gonna do is we're gonna put the rocker arms, put the push rods, we're gonna put everything else on this, and then we'll go and we'll do it with the rocker arms on, and we'll finish the other 3 so that you can see how that's done. And then if you do that, you don't have to have these tools because the rocker arms will hold that in, will hold them down. Okay, so while we're setting up for this synchronization and the overhead set on this engine, I'm gonna go ahead, since we're building this engine, I'm gonna go ahead and check the rack setting as well so you can see how that's done. So on the rack setting, where's those ice scripts? On the rack setting, what you do, if you're doing this without removing the valve covers, there will be a metal shield. Is that, still got that metal shield for this? There's a metal shield that goes on here, and it goes up right here on the rocker arms. And that's just a tamper-proof, tamper-resistant device here to keep you from being able to get to the rack setting. So what we're gonna do, the way you do this is you zero the rack. Let's see, okay, so I was gonna show you how to adjust the fuel setting, but my rack is stuck. See, these are stuck in place. The reason they're stuck in place is because we took the compression bars off of the fuel injectors. So we've taken the compression bars off the fuel injectors, so now they're stuck. So we have to finish put the rocker arms on here first, and then we can go ahead and I'll show you how to adjust the rack. Okay, so we're gonna go ahead and we're gonna run the overhead on this, and we're gonna finish synchronizing the fuel injectors. But while we're setting up, we're building this engine, and so we need to also set the rack on it, the actual fuel setting, in case you decide you need more fuel or something. This is how you do it. So right here, you set, and you need the factory tooling to do this. Unfortunately, there's no good way around it. This is the same tooling, or part of the same tooling used to do the synchronization. This is stuff that we don't use. So you find the rack setting. There'll either be a sticker or a plate or something, hopefully still on the engine. You can actually get the engine performance specs from the CAT dealer. We can also help get those numbers for you if you need, just by going off of the engine serial number. Anyway, so this one has a full load static fuel and a full load dynamic fuel setting or a full torque fuel setting, I'm sorry, of 7.10 millimeters. Now, if you're accustomed to any other Caterpillar engines that have a torque rise, the full load and the full torque will usually be quite different. On these engines, they don't do it that way. That's all calculated in the governor, and so they only give you the full load setting, and the full torque will always be the same. Okay, so we want to hit 7.10 millimeters is what our rack setting is. So the way you do it is you set this tooling up on the #1 fuel injector. Now I told you earlier that the #1 doesn't synchronize. That's because it's connected directly to the governor through the rack setting, and then the other 5 do what #1 tells it to do. So what we do here is we 0 our rack. Okay, so we had to put a little bit longer point on this to make it work. So what you do is you 0 the rack. The way that you do that is you put this tool on the end of the same rod that we've been synchronizing, that we've been going off of, but on #1. Now also, here is the small metal cover, the tamper-proof cover, and it normally goes right there. We've removed it so we can see what we're doing. But that is your actual rack setting. Okay, so now we come down and we 0. It's nice to have a digital dial indicator because you just hit 0 and start over. But whatever you have, and this is also in metric, so you need to have a metric setting. Okay, so what you do is you 0 your rack. Okay, and that's just where this stops at the bottom. Okay, then this is all in the tooling kit. So if you don't have the tooling kit, you're kind of out of luck. So right here in the governor is the roll pin that connects the rack to the governor has a hole in it. And that hole, you pull that down, and where that roll pin and this pin touches the governor, you put this fork in place. And you don't put it tight, you just put it kind of loosely in there. Okay, so that gives us a rack setting on this engine of 6.98. Okay, now our setting is actually 7.10. So we're going to give it just a little bit more here. Okay. Now it's changed a little bit just since I backed it off and unlocked it. Okay, so we'll run this down. To 7.10. All right, now we've got to check it a few times. So you come down to 0, and you come back till that touches. Okay. Now where it touches is where you want to be. So this is plenty close. For what you're doing for your rack setting. That's close enough for me. Now, you don't have all this tooling, all this Caterpillar tooling and everything else to do this job with. If you're doing one, you can usually, these are usually fairly low horsepower engines, especially in equipment. You can safely give these a 1/4 turn to a 1/2 turn of extra rack on them. They usually won't really affect it a whole lot. It'll help the horsepower a little bit, and they can usually handle it fairly well. There's not a problem with it. If you get excessive smoke under load, then you can back this off slightly, and it usually doesn't even affect your horsepower too much. So you can kind of play with that and just go with your smoke under load, and that'll give you a fairly good idea what your rack setting is. If you feel like nobody's been messing around with it, if somebody's been messing around with it, then it's a good idea to probably at least get the baseline of where it needs to be. Anyway, I just want to show you a little bit about what this is and where that is, but unfortunately you do have to have all the tooling to be able to do it properly. Okay, so now we've put all of the rocker arms on. We've adjusted the rack setting. Now we went ahead and we did 4 of these with all of the rocker arms off. We synchronized 4 of them. So we have 2 more left to do. And you can do this here just as easily with the rocker arms on. This is good if you ever need to change a single fuel injector, because then you only have to go in and you only have to just synchronize the one with the other ones. With the tooling, with the Caterpillar tooling, it forces you to take the number 1 rocker arm off, or to synchronize off the number 1 and whatever one you're dealing with. This way you can just change a single fuel injector. Okay, so I'm coming down, I feel my first light bump. My first light bump is here on number 4. Then I give it another flick. And you can see that move right there. And it's easy to see when they're a ways off, but it's very difficult, and it takes a very light touch to be able to figure out what you're looking at. Unfortunately, you got to be a little aggressive at it, but you still got to be able to feel that contact point. So I'm feeling this contact point of being right there, and then I flick it just a little bit more and see that. Okay, so now you can get this tool, and again, this is why it's important to have this one tool or make your own. Get down in here, okay, and I always like to keep the lock nut fairly close to where I'm at. Don't run the lock nut out 4 turns or anything like that. Okay, back it off. I usually bring it in about 30 degrees at a time, something like that. It's usually what I bring it in. And you got to come up here so that it's in line. If not, it'll jam down by your fuel injector. So you got to come up here. So take that off. Okay, come down. Feel the light touch. There's still just a little bit more. Feel the light touch, and then a little bit of bump after that. So just another 10 degrees or so. Look up here on this one. Yeah. Okay, back to this one. Okay, you need to always be looking at the one you've already done to make sure you don't have any contact, or this one hasn't gone too far, and then your movement transfers over to here. That feels pretty good. Okay, so I'm going to lock that one down. Now we're going to go to number 6. It's back down here. You got a shadow right here. Come pull it on. There you go. Okay. Okay, so now you're going to come down to the contact. You touch. You feel the light touch. And a movement. Light touch. And the movement. Light touch. Movement. Light touch. Movement. Okay. Now, back this off here. I'll go quarter turn or so. He's jammed. It's in there. Okay. Okay, now the light touch, movement. Light touch, movement. Light touch, movement. Another 30 degrees or so. Light touch, movement, light touch, just got a little bit of movement there. I'm gonna go quarter turn. Okay, quarter turn. Okay, light touch, movement, light touch. Okay, now at the very first of this, you saw that I moved all of these out of the way. I deliberately moved them clear out of my way. The reason you do that is because you need to be able to feel that touch. And if you got all 6 of them coming down at once and they're off, it's harder to feel that. It's better to see an aggressive movement here and then zero in on it with your eyes, because this is very, very difficult to see. Okay, so still gotta go a little more. More. Okay, feel the light touch. Loaded. No more movement. Now come back here, Dan. Let me look at this one. Go back here. Okay. So that's pretty good. I can hit it pretty well without having too much of a struggle because I've done it many, many times. But it takes a while to get the feel for it. Once you get the feel for it, then it'll work fairly easily. So, okay, so now we've gone through all those. Now what you need to do is you need to do the entire thing. So start from 1 and work your way down. And look at them all and make sure that when it hits the bottom, when you feel the stop, you don't see any more noticeable movement on anything. And a good bright light shining down on it is the very best thing to do. Sometimes if there's oil or some brake clean in there, it will actually help you, because that little bit of light movement will cause a little ripple in the fluid, and it's a little bit easier for your eye to pick up on it. But anyway, the whole concept of all this is just that they all have to touch down at the exact same time. Okay, I feel pretty good about that. Okay, so there's the injector synchronization. Now the injector synchronization can be done at any crankshaft position. You don't have to be on number 1 TDC, number 6 TDC, anything else. The next step, where we adjust all the valves and we adjust the fuel injectors, now we have to put it on number 1 TDC and number 6 TDC to do that, and that's what we'll be doing next. But as of right now, the injector synchronization, the rack synchronization, is done. Now we have to go through and we have to adjust the valves and adjust the timing of all the injectors. Okay, so we have to find top dead center, number 1 top dead center on this engine. We're gonna run an overhead on it, and the way, you can do it however you like, but the way that I like to do them is I make a heavy paint mark on all of my injectors and my valves that are done on number 1 top dead center. And I always leave them in there, and they'll usually be, in the future, those marks will still be there, and then I can always grab it, and if I come up on number 6 TDC, I know that I've marked number 1. I just do the ones that are not marked. And every engine that I build, that's the way that I do them, so that we can see that later. Now, another thing that you can do to find top dead center, if you get in the book, it tells you to roll it around until you pin time it. Well, that's a good thing to do. Unfortunately, a lot of these engines that are in machines, the timing pin is difficult to get to, the the vibration dampener, the turning tool, whatever it takes to turn it is very difficult to do. This needs to be close to top dead center, but it doesn't have to be exact on top dead center for the way this needs to work. So we have already pin timed this once, so we know where the pin mark is on this with the pin timing. But I'm going to roll this over just by look and feel of when you get the number 6 fuel injector in rollover, that will put the number 1 fuel injector at top dead center. So rollover is when the exhaust valve closes and the intake valve just starts to open. At that point, that is number 1. That's the start of the intake stroke on the number 6 cylinder. And if you hit that close enough, that's close enough for what you have to do here. You can even do that with a start button on the starter and bumping it over slowly. And I've had many difficult times trying to hit this in a machine because I couldn't reach the vibration damper, couldn't reach the turning tool, couldn't get the pin in. So that's how we're going to do this. Okay, so bring it up, and I'm going to tell you when to stop, and we're going to see how close we get to the timing pin, okay? Okay, so exhaust is closing, exhaust is closing, exhaust is closing, intake is opening right there. Right there. Okay, how'd we hit? Where do we end up?
Perfect.
Okay, this mark, so we ended up exactly right where we needed to do. So what that is, these are backed off a little bit, but you'll feel that as soon as the exhaust closes and the intake opens on number 6, that puts your number 1 on top dead center. Now exactly the same thing happens if you're trying to find number 6 top dead center. If you're rolling it around and you're trying to find it, so you don't have to bump it with a starter or do whatever you have to do, you can come in and you can find number 1 rollover, which will give you the number 6 top dead center if you wanted to get to that point. Okay, so this is the Caterpillar tool that comes in the toolkit, but it's just a 15 thousandths and 25 thousandths feeler gauge. That's all you got to do. Your intakes are 15 thousandths. So we come in on an exhaust valve. I'm sure there's all kinds of arguments that could be made on how people adjust valves, but this is the way that I like to do them. I run them up till they are a little tighter than I like them to be. Hold the screwdriver in that position. Then, when I tighten the jam nut, it backs it off slightly, and it gives me just the right amount of drag on that cylinder. And again, that's another feel, another practice. That's another thing there's years of experience that have to happen to be able to get you that. But you have to have a slight drag when you're pulling these. So again, we just walk down, and now all we got to do, the way that I've marked this, we don't have to know what ones we've got. We don't have to worry about that. We've pre-marked everything. So now we just walk down the line and we do all the ones that are painted. Okay, so we give this a little bit more than we want, so it's a little harder to pull out than we want. Tighten it down while you're holding tension on it. Then at this point, you give it a little bit of tension in reverse so that it doesn't move. Lock it down. That's a little bit tight. Well, let's see. Oh, that's actually good. Okay, that's good. I think I've seen most guys will get these too loose because they don't get the proper drag on them. So what you want is you want to be able to lightly feel with 2 fingers and have a bit of pull or a bit of resistance. Now, depending on the age of the engine, everything else, they can get a divot in them. They can get other things in them that can cause them to, your feeler gauge will actually be a little tight, but the actual 2 contact points of the rocker arm and the valve will still be within spec. So it's better to be a little bit tighter, especially on older engines that it's not a fresh rebuild. Okay, so we go through here. Run it down. Run it down tight. A little loose. Now the Caterpillar tooling has some nice deep offset snap-on wrenches that they use, and if you have a set of deep drop offset wrenches, they work fairly well, but it's just one more tool you have to buy that you don't need. But they are handy. As these engines get older and they've had more and more overheads done on them, I think that the adjusters tend to wear out and they stretch a little more. And they become a little harder to gauge. There we go. A little harder to gauge how far to overdo it. Okay, can I borrow that, Anna? Thank you. Okay, that's all the valves are adjusted now. Well, half the valves. Now we're going to adjust the 3 fuel injectors that we marked. Okay, cut. Okay, so now we're going to adjust the timing of the fuel injectors. This is the Caterpillar tooling. The Caterpillar tooling has a standard. And the standard is 62 millimeters. And what you do is you rig all this stuff up, and this is all preset. I'm not going to go into this very much, but it's pretty involved, getting the preset working right, making sure that it reads positive rather than negative. So anyway, what you do is you put this in here, you put it in the preset, that gives you that preset of that, if you're ever using this, you need to make sure that when you go up, it counts down. It's very difficult to make that work properly. Sometimes it counts the opposite direction, and it can get you in a lot of trouble. Okay, so now when you go to make the measurement, it's just direct reading. Okay, you put it over the top of the fuel injector on the top of the spring, and then there's a ledge down below here. Okay, so what I get here is I get a reading of 65.04 millimeters. Okay, now this is the part that I want to show you. We're not even going to use any of this. Okay, I just want to show you how that works. So all you need is a caliper, and I prefer, for what we're doing, I prefer a digital metric caliper. Makes it easier. Then all you got to do is you come down here, come across here, there's a small ledge down here, and you just run down, you make your measurement. So I got 65.07 is what I get out of this. Okay, so what do you adjust them to? Every one of these engines, based on the arrangement, the horsepower, everything else, is a different setting. So what you want to do, if you can find the data tag, the sticker, or the data tag on the engine, it'll have it. It'll say fuel timing. This one is 64.33 millimeters. Your Caterpillar dealer can give you that timing spec. We can also help you out finding that. If you get in the engine performance specifications, it's also in there as well. What I like to do, especially if you're at altitude or in cold weather, I always advance the timing roughly 2 degrees. So 2 degrees, and it's within the timing tolerances of the engine, is plus or minus 0.25 millimeters. These engines, as they wear to where this number goes higher and higher and higher, and so it retards the timing. So just about any one of these engines that's run for a couple of years, the timing will be off, and it can make it a little bit more difficult to start. So whenever I do one, I always find the fuel timing spec that we calculate, or that we get, is 64.33, and I minus 0.25 from that, so that will give me 64 point, what is that? 0.08, 64.08. Okay, so we are going to set this engine at 64.08 millimeters, which will be the spec, plus it will advance the timing slightly. It'll advance it about 2 degrees. And if you're at altitude or in cold weather, that'll help its cold starting quite a bit. Okay, so we're going to do number 3. We just have to keep working it until we hit what we need to hit here. I like to push down, put the pointer on the ledge and then push down. That gives me 64.05. So I'm going to come out just a little bit, and that'll give me 64.06. Okay. So right there, that gets us close enough for where we gotta be. Okay, so now you just do the other two. So you'll do two, then you roll it 1 revolution, and then you adjust everything that is not marked, and your overhead is complete. Okay, so now we've done all the injectors, all the valves, rolled it over 1 complete revolution, and done the other half of them. So the entire overhead is done now. We've advanced the timing 2 degrees ahead of spec. Like I say, that helps. It helps them last a little longer because they wear roughly a degree or 2 every 2,000 hours. So that'll give you an extra year or so before it needs another overhead again, before it's out of spec again. Anyway, as you can see, it sounds intimidating. You read the book, it is intimidating, but really honestly, with a few basic tools and things like that, it's really fairly simple to do. Anyway, so we're gonna test run this and see how it works. Okay, so stay tuned for more. This is Heavy Equipment Technical Support. We are going to start putting some more videos online and some more content online, so subscribe, like, tell us what you think. Thanks.